Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we will learn about the Superheterodyne Receiver. Okay, still remember this plot diagram? So previously you have learned about this basic plot diagram of communication system where we have the transducer, transmitter, transmission medium, receiver, and then the output transducer. So in the transmitter, so the modulation process happen here. And then in the receiver, demodulation of detector of the modulated signal is happen here. So that's mean in the transmitter, VMT change to the VAMT, and then in the receiver demodulation process, VMT change back to the VMT, the information signal. Okay, so for today we focus on the receiver. This means demodulation is one of the process in the receiver. So there are many other process in the receiver. So today we will go through this component. Okay, what is the feature of good receiver? So for a receiver, it should have adaptability, where the receiver should adaptable with the system, and then should have fidelity. With fidelity is specify the ability of the receiver to reproduce all the frequency component of the transmitted audio signal. So it's produced back. So if the fidelity of the receiver is high, then the clarity of the reproduced audio signal is also be high. So fidelity is this mean because in the modulation, VMT change to the VAMT, and then it's reproduced back the VMT. So if is the fidelity is high, so we will get the high clarity of the VMT. And then it should have a sensitivity which specify minimum possible strength of the received signal to be maintained to produce corresponding fruitful output. And the last one is selectability, which the ability of the receiver to allow only desired frequency component and reject, attenuate all other undesired frequency component. Okay, so how this feature is affect our communication is, for example, if the receiver has poor sensitivity. So for the sensitivity, it is about the output. So this means if the sender send you a data, but the output not get the same as the input. And then if the receiver has poor fidelity, fidelity is about the how reproduce signal is same as the input. So for example, if has poor, that means the input not same as the output. And then if the receiver has poor selectivity, so it's not get what the information from the sender. A good solution to overcome this problem is using superheterodyne receiver. It's the major breakthrough in the communication field. Okay, so for the radio receiver, there are many type of the radio receiver. We have the tune radio frequency regenerative receiver, super regenerative receiver, super heterodyne receiver, and direct conversion receiver. But for today, we will cover on the super heterodyne receiver only. Okay, what is super heterodyne? Okay, super heterodyne is the heterodyning is the process of mixing two signal having different frequency. So amplitude modulation is a heterodyne process because the information signal, because we have a VMT information signal is mixed with the carrier signal. So the high frequency carrier signal. So amplitude modulation also is the heterodyne process. But for superheterodyne is the process of creating a bit frequency that is lower than original signal. So the purpose of the superheterodyne is to mix in another frequency in the receiver so as to reduce the signal frequency prior to the processing. So before we process the signal, you want to reduce the signal frequency. Superheterodyne receiver convert every selected RF signal to a fixed lower frequency called intermediate frequency. Okay, intermediate frequency. What is intermediate frequency? So RF signal, we have high range of radio frequency signal, and then for superheterodyne, it will translate into one value of frequency that is intermediate frequency, which the value is 455 kilohertz for the purpose of amplification, filtering, and demodulation. This means in the receiver, we have the process of amplifier, filter, and demodulation. But before we go through the amplification, filtering, and demodulation, we change or we translate the frequency into intermediate frequency first. The device that performs the modulated signal frequency translation is known as frequency mixer. The operation is called frequency mixing or conversion or heterodyne. So this is the formula of to get the intermediate frequency, where FLO is the local oscillator frequency, FRF is input of the receiver or the modulated signal, and then FIF is the 455 kilohertz. Okay, what are the components in superheterodyne receiver? So we have 5 major part in superheterodyne receiver. That is, the first part is RF section, and then the mixer or converter section, where the superheterodyne is happen here. Superheterodyne process is happen in the mixer. So here in the mixer, it will produce the frequency output is FIF. So this is FRF and this is FLO. And then the intermediate frequency will go through the amplification and filter in the IF section, and then go through the detector section and amplifier section. Okay, for the first section is the RF section. The first section of radio receiver is always a RF section, with is the tunable circuit connected to the antenna terminals. It is used to select only the desired RF signal out of number of frequency to the receiver. So the RF amplifier is tuned voltage amplifier and contain LC tune circuit. So this means here we have many signal, and then it select only certain range of the frequency that related to the to the information signal. So the RF amplifier is a tune. This tune circuit select the desired RF signal from a tune of frequency to the receiver, and the second purpose of amplifier is pre-amplification. So before it go through the mixer, it amplify first the signal. Then the amplified RF signal is fed to the mixer stage, where the RF signal is mixed with a high frequency generated by a local oscillator. So here we have the uh, modulated signal with already, that's mean the amplitude already amplified by amplifier, and then we have local oscillator here. Here in mixer, the mixing process happen here, where the FRF, or here is, we call it as FS, and this one is FO. So the mixing of the selected RF signal Fs and the local oscillator frequency Fo produce two additional frequency, Fs plus Fo and Fs plus minus Fo. So the output here is Fs plus Fo and Fs minus Fo. So the difference in frequency Fs minus Fo is always adjusted to be 455 kilohertz. This is based on the formula here. FLO equal FRF plus minus FIF. So the formula before this is FLO equal FRF plus minus FIF. Okay, and this equation can be interchangeable for this mean here the Fs is FRF here. So this mean the FIF, this mean the output of this mixer is also equal to FRF plus minus FLO. So the FIF is constant. So constant. So we have 455 kilohertz, and then so based on here we will change the FLO. So for example, we have the modulated signal with the 400 kilohertz, and then FIF is 400 455. So the FLO that we should use here is 855 kilohertz. Okay, because here, for example, if the FLO is 855 kilohertz, and then Fs is 400, so the difference between is 455 kilohertz. So that's mean the output of the mixer is plus minus, but we usually consider minus. That means the difference between local oscillator and RF should be 455. So this local oscillator is the frequency of the local oscillator will change. to get the output of the mixer is 455 kilohertz. Okay, at the mixer stage, with the help of gain capacitor, the local oscillator frequency is always adjusted to be above RF signal frequency by an amount equal to intermediate frequency. So here we have capacitor, and then it will change the frequency to get the amount, that's mean the difference between these two frequency is 455. Okay, so that's mean for the IF signal, even the input have many, that's mean the F is different, but here the input of IF section, the F is constant with the 455 kilohertz, the intermediate frequency. So the IF amplifier are fixed tune amplifier with a tune to the intermediate frequency. This amplifier give a very high amplification to IF signal. The advantage of the IF filter is opposed to RF filtering, that the filter can be designed for a fixed frequency. So here for the RF filter here, the filter is depend on the output. Depend on the input, which range that you want to select. But here, for the filter in the IF section, the filter is fixed. That means designed for a frequency with the band pass frequency 455 kilohertz. So this allow for much better tuning. Variable filter are never able to provide the same level of selectivity that can be provided by fixed frequency one. So this is the highlight why they come out with superheterodyne, because when the circuit use the same, that means the fixed circuit, it will produce better tuning and then better selectivity. So for here, it will only choose 455 kilohertz for the filter and also amplifier. So it's create better system. And then after that is go through the detector section, where the output of the IF amplifier is applied to the envelope detector, where the audio signal is extracted from the AM signal, and diode is commonly used for AM demodulation. RF signal is suppressed by the filter circuit. The last one is amplifier section. Once demodulated, here demodulated, we will get back the VMT, but the signal is still low magnitude. So to amplify it, we use the audio amplifier to this means to amplify the signal. So this is the 5 part in the superheterodyne receiver. Okay, the advantages of the superheterodyne receiver are it improves the sensitivity, because it's only sensitive to, that means it's select the IF frequency 455 for the most of the circuit. So it improve the sensitivity of the receiver, and then it has high adjacent channel rejection. So the adjacent channel will be reject, and then the gain is stable and no bandwidth variation over the tuning range, and better selectivity. Okay, these are the advantages of superheterodyne receiver. Okay, that's all for the superheterodyne. Okay, thank you.